Today let's talk about writing exponential equations. Today I'm going to show you two different ways to write exponential equations depending on what the directions are telling you. Okay? I know you're super excited about that, but I need you to stay calm. What's the basic form, the general form, the standard form for an exponential equation? So y equals a times b to the x. Are you in agreement with that? That's our general form or our standard form for an exponential equation, right? Okay. So what's going to happen is I'm going to say, I want you to write me the equation, the exponential equation that passes through these 2 points. Okay? Sounds easy enough, right? Guess what? It is. Start with the first point. We're going to substitute each point into standard form. One at a time, we're going to substitute each point into our standard form. And this is x and this is y, right? And this is x and this is y, right? I mean, I know you know that. I'm just labeling it for us to help us out a little bit more. Is that okay? Okay, so y equals a times b to the x. Easy or hard? Easy, right? Okay, now do it again with the other point. Just separately, not in the same equation, but separately. Y equals a times b to the x. You got it? Okay. Choose one of the equations. I'm going to choose this one because to me this one looks easier. Numbers are smaller. Yes? Solve one equation for a. It doesn't matter which one you choose, but solve one equation for a. So I already told you I'm choosing this one, right? So I'm going to divide both sides by b to the first, which is just b, isn't it? So I get a equals 6 over b. Any questions about that? Substitute a into your other equation. So take what we know for a and plug it in the other equation. So 54 equals a, except a is 6 over b times b to the third. B to the third, excuse me, b to the third is really over 1, right? So when I multiply straight across, I get 54 equals 6b to the third over b. What can happen right here? When I'm dividing like bases, what do I do with the exponents? When I'm multiplying like bases, what do I do with the exponents? Add. Okay, so when I'm dividing like bases, what do I do with the exponents? Subtract, right? What is 3 minus 1? 2. So I get 54 equals 6b squared. Here's another way to think about this. B times b times b is the same as b to the third, right? Divided by b. B divided by b is 1. What are we left with? B squared. Does everybody understand? Solve for b. Solving for b means I'm going to divide both sides by 6. B squared equals 9. What do I have left to do to solve for b? Square root? Good. Anybody know the square root of 9? Oh my goodness. Yes, 3 is correct. Excellent. Anybody know the square root of b squared? Yeah, that's the whole reason I square rooted it, right? Okay. Now that I know what b is, what do you think I'm going to do with it? Yeah, substitute b. Into the equation that's a equals. So go back here. So 6 over 3 equals b. Does anybody know what 6 divided by 3 is? Don't you say no. Oh my goodness. B equals 2. So in order to have an exponential equation in standard form, what do we have to know? A and B. Look. Well, I wrote the letter wrong. This is supposed to be A. You saw that and you just didn't fix it? Rude. Sorry about that. A is 6 over 3, so we solved for A and got 2. We need A and we need B. Look, I got A, I got B. Now all I have left to do is actually write the equation. So write equation. So what equation am I writing? Y equals 2 times 3 to the x. Got it? Would you like to do another one of those? Yes? Okay, awesome. That sounded super excited. I'm happy about that. Here we go. 2 and 24 and 3 and 144. So what do I do first? Substitute each point into standard form, right? So just to kind of help out, this is x, this is y, this is x, this is y. Is that necessary, what I just did? No, you can totally do that in your head. I'm just helping us out with our notes, okay? So y, so 24 equals a times b squared. And then do it again, right? 144, which is y, equals a times b to the third. Okay. Solve one equation for a. Which equation would you like to solve for a? First of all, does it matter? No. Second of all, which one should we choose? Why do you think we should choose this one? It's smaller. You okay with that? So solve it for a. How are we going to solve this for a? Divide both sides by b squared. So a equals 24 over b squared. What do I do with this? So go over here, substitute into the other equation for a. 144 equals a, which is 24 over b squared times b to the third. Now solve for b. Well, what can I do here? What can happen right here? So one's in the numerator and one's in the denominator, so what do I do with their exponents? Subtract, so it's 3 minus 2. So 144 equals 24b. So how do I solve for b? So divide both sides by 24. What does b equal? Good thing you have your calculators out, because I wrote it on the board. Yeah. Yeah, if you don't have it out, now's a good time to get it out. 6. Now that I know what b is, what do I do with it? So go back over here, right? Okay, so 24 equals 6 squared. I skipped a step. Are you okay with that? I didn't write 6 squared and then write 24 over 36. So what does A equal? I really don't want a decimal because then it's rounded and then it's not as accurate. So hopefully you notice that both of these numbers are divisible by 12. Also 12, right? Yeah. So 24 divided by 12 is what? 36 divided by 12 is what? Yeah. You could put it in your calculator and you would get 0.6 repeating, right? Hopefully you know that that's 2/3 and you would write 2/3 instead of rounding. Okay. You're not going to have to round on any of your answers today. I want them as decimals. Okay. Except what I meant was fractions and you knew that. So sorry about that. No rounding. Okay. Unless it's a perfectly exact decimal like 0.8 or something like that. Give it to me as a fraction. Fair? Now I need the equation. Because we found A and B both, so I need the equation. Very good. Any questions? Okay, so that's standard form, right? Well, there's another kind of form that you can write exponents in called recursive form. I don't know, I always feel like I should write recursive in cursive. Maybe it's just me. Maybe I'm just weird. I know I am, but you know. Now, for the record, just to clear up previous misunderstanding, this does not mean that we are cursing again. We shouldn't have been cursing the first time, right? We're not. That's not what this word means, okay? It's just a form. It's a way to write an exponential rule, okay? So just to make sure that we're clear, the exponential rule or the general rule looks like what? A times b to the x, right? We just talked about that. So here's what the recursive rule looks like. F of 0 equals A. F of n equals R times f of n minus 1. Now, for the last stuff, I had 2 examples for you because I thought we would need to go through it twice. Okay? For this type, I have 3 examples for you to prove that it really is as easy as it looks after the first example. 2 just doesn't seem to prove that it's as easy, so I did 3. Okay? So if I tell you f of x equals 6 times 3 to the x, what do you know? What's this? A. And what's this? B. Are we clear on that? Now, if we're looking at the recursive rule, we don't have an A and a B. What do we have? A and R. Thinking back to when we talked about tables, where was A in our table? The starting point, where x equaled 0. Yeah, when x equals 0, that's what A is in our table. Okay? Well, look how recursive form is written. F of 0. Doesn't that make sense that this used to be an x and now it's a 0? So wouldn't f of 0 equal our A value, which is 6? Think back to our table. Where did we get our B value? What was it? It was as we moved up. Yeah, we divided. As we moved up the table, we divided a term by the term before it. So we actually called that our common ratio, didn't we? What does the word ratio start with? R. Good. I'm glad you knew that. But that's going to be also our B. So f of n, first of all, in a sequence means any particular term in the sequence. I can find any particular term in the sequence if I know the common ratio and f of n minus 1, which is the term before it. And that's the answer. So you're telling me that I just say f of 0 equals a, and f of n equals b times f of n minus 1, and that's the answer? Yes. F of x equals 8.32 times 1.44 to the x power. What is f of 0? Yeah, say it out loud. And what's a in this problem? 8.32. And what is f of n? What does it equal? Times f of n minus 1. Done. Are you starting to believe me that it's easy to go from exponential to recursive? Okay, one more try, one more time. F of x equals 1/2 times 3/4 to the x power. What is f of 0? 1/2. What is f of n? Perfect. 3/4 times f of n minus 1. So making sure you understand, what does f of 0 actually mean on a table? It's where x equals 0. We know from our talking about a and b this whole time that a is our initial value or our starting value when x equals 0. That's why f of 0 is always a. Okay? F of n, any number in the sequence that we choose, that we try to find, we just need to know the common ratio times the number before it. So if we're trying to find f of n, does it make sense that the number before it would be f of n minus 1? If I'm trying to find f of 9, what else do I need to know? F of 8. If I'm trying to find f of 7, what else do I need to know? F of 6. Does that make sense? So like if I'm trying to find the 10th term in the sequence, I also need to know the 9th term, the term right before it. Does that make sense? First term in the sequence is where f of 0 is at f of 0, that's a. Any term in the sequence is the common ratio times the number before it. Questions? Got it?